world's highest tides are at the Bay of Fundy. So now again, unlike the first one, we don't have much information. We just have enough information to start graphing this. So what we do is we go to our graph and we start putting some information on here. The other difficult thing about this one is that we've got times that are in hours and minutes, and that's going to be difficult to figure out how are we going to put that on our x-axis. How are we going to put our time on our x-axis? So the first piece of information, we find out that we get a maximum of 8. So that's going to be my maximum at 8 at 4:30. So if I choose a certain distance along here, let's say I choose this for 4:30, what number should I write underneath that? 4.3? 4.5? What makes most sense? 4.5, because 30 minutes is exactly half of an hour. So when we're dealing with time, we're going to have to do some changes here. Now, it says it hits a minimum of 2 meters (6 hours and 12 minutes) later at 10:42. So first of all, if this is 4.5 hours, this spacing, I'm going to have to make 6 hours a little bit wider. Does that make sense? So when you're setting your axes up for your graph, you got to be aware of your spacing. So that if you make this 4.5, this first spacing, this next spacing is going to have to be a little bit bigger because it's 6 hours. Now 10:42, what should I put as my decimal here? 10 point what? Should it be higher than 0.5 or lower than 0.5? Higher, because we got more than half an hour. Now how are we going to figure out exactly what number is going to go in there? So we got 42 minutes, right, out of how many minutes in a whole hour? 42 minutes out of 60 in an hour is what decimal? 0.7. So that's how we could change that to a value that we could work with, 10.7. Now notice between those two is how much? Up 6.2. And this is the only information we have. At 4.5 we have our maximum. At 10.7 we have our minimum, and we're told that it's periodic in nature. So a couple of things that we've started to notice with our graphs of our periodic functions for sine and cos. Notice that we always separated a full period into 4 equal sections. And that when it started, it went from, like cos would go from max to centerline to min to centerline to max. And that would be all of those sections. So first of all, from those 2 points, can you tell me where the center line is? It's going to be at 5. Right here in the middle is going to be at 5. And does it make sense that between this maximum and the minimum, it's going to hit the center line right in the middle there? What value is that going to be at? 7.6. And how did you figure that out? So you figured out that half of this 6.2 was going to be 3.1, and you added that on. Does it make sense that our graph is going to get back to the center line right here? What value is that going to be? 13.8. And then it's going to get back to our maximum right there at 16.9. And now we've got those 5 points. We can draw a nice smooth curve between them. And with that, we should have enough information to make our equations. Now this question asked us to make an equation once with sine and once with cosine. So based on that, to make our equation, we need to know our d, our a, our b values, and then we'll figure out c specifically whether we make a sine or a cosine graph. But our d, our a, and our b values are going to be the same for both sine and cosine. So first of all, what's our d value? Close. D value is our center line. So our center line is going to be 5. What's our amplitude? Distance from that center line to a maximum or a minimum. Our amplitude is going to be 3. Now our b value comes from our period. Our b value is equal to 2 pi divided by our period. So looking at our graph, can you see what our period is? 6.2 takes us from a maximum to a minimum. Can you see that that's half of our period? So our full period would be 12.4. Because if it's 6.2 from here to here, it would take another 6.2 to get back to that maximum to make one full period. So our b value is going to be 2 pi over 12.4. And I wouldn't simplify that and I wouldn't change it to a decimal. In fact, I really like writing my b value as 2 pi over something, because then I can see right from my equation that my period is 12.4. So now that we've got the d, the a, and the b value, we can set up both our sine and our cosine graph. Our a value is 3. I'll leave some space in front in case we decide to make it a negative sine graph or a negative cos graph. One equation with sine, one equation with cos. Our b value is 2 pi over 12.4. So that'll be the same for both of them. I'll leave some space for our c value here, and then our d value is plus 5 plus 5. Where does sine start? Sine starts in the middle going up. Can you see on our graph we have 2 of those points? We have a point right here on the middle going up. We have a point right here on the middle going up. Now, according to our graph, the only one that we have labeled right now is the 13.8. So you could write x minus 13.8. That would be perfectly fine, and that would be correct. Most often, if graphs are written out, they will try to find the closest one. So how would I find this one? What do you think that would be? 4.5 minus 3.1, which would be 1.4. So if you were graphing this, you would probably, because of what you've labeled, write x minus 13.8, and that is perfectly correct. But if you looked in the answer key at the back of the book, you might have seen x minus 1.4, and now you know, oh, that's what they did. That's how they came up with that answer. And that is in the middle going up, so that's a positive sine graph, so we don't need to put a negative in front of the 3. For a cosine graph, where does cos start? At a maximum. So here we have our maximum, our closest maximum right there. And that happens at 4.5. And again, since we're starting at a maximum, that would be a positive cos graph. So we've got a new scale, a new equation. Choose one of those equations, put it into your graphing calculator, estimate the depth at 130, and then use your graphing calculator to check how close your estimate is. I'm going to type the cos one in just because it's the only one I can see. Clear out our other data. y equals 3 cos. I always forget that they give you a set of brackets. So once you've typed it in, setting up our window, we're going up to 16.9, so I'm going to go a little bit further up to 20. And we're only going up to 8, so I'll go up to 10. And there's a picture of our graph. Where would 1:30 p.m. be on our graph if we were estimating? $13.5. Sort of have to think in a 24-hour clock. So if you went up and over, might estimate that to be somewhere between 3 and 4 or 4 and 5. Looks like mine's right at 3.5. Now, how accurate is my estimate? I can go second, calculate that value at 13.5. It's 4.5. So my graph and the way that I drew it wasn't super accurate. And that calculation is a lot better. So you have 2 questions left on our page. Those 2 you're going to try on your own. You can work in small groups or you can work by yourself. So I'd like you to try those 2 examples on your own. If you get done those 2 examples, some of you have a homework listed at the bottom of the page that you can put a line through. The one out of your textbook will be on page 548. And you can work through questions 3 through 9.